If you want your AI agent to be able to answer questions based on your spreadsheets and databases, then traditional vector stores will usually give you very poor results. Ask your agent a simple question like, what is the sum of all of my orders? It will go to the vector store and then retrieve the top semantic results for that query. And that could be chunks of this document along with other documents completely out of context. An alternative to this is to use agentic RAG. So instead of storing all of our company data in a vector database, we can choose to store certain structured data within a standard relational database. If you're using Supabase, both of these can be stored within the same project. When we ask the agent a question, it can choose to either get semantic results from our vector database, or it can get precise quantitative results from our structured data using NLQ. NLQ stands for Natural Language Query. In this workflow, we're going to be ingesting spreadsheets and storing those into our relational database. We're going to be storing the overall schema info for the sheets and store those within one single table in our vector database. This is a highly flexible approach, and it means we do not need to have a different database table for every different type of data structure. Once we ask the agent a question, it can choose to get the available datasets and schema information for those. Then it will create a SQL query where it can then get lightning fast, accurate results from the database. But for other questions that don't need answers based on structured data, the agent can choose to query the vector database instead, where it can get answers from the unstructured information that's stored as vectors. Let's start with a quick demo. Within my database, I have a central record manager table, which is an overall lookup of all of the documents that we have in our database. So this will cover unstructured documents, which are stored in the vector store, as well as tabular data, which is stored within our relational database structure. In this case, we've ingested two spreadsheets to the system. We have this CSV file with 1,000 rows and this Google Sheet, which is a sample data set of rolled up analytics data. So within the agent, I'll ask it to give me a breakdown of orders by country. Now let's wait for the result. It has got the data sets from the record manager, and then after that, it queried the tabular row. So it's responded with the total count of each of those orders for each country. So if I go into Excel, I can just select all of those, create a pivot table. On the right-hand side, I'll select country and total order amount. And instead of sum at the very bottom right, I'll go to value field settings and then go to count. Then at the top left, I'll go more sort options, sort by Z to A. So I'll sort by the second column here. So I can see based on this pivot table that the response we got back from the agent looks perfect. So this is summing this across 1,000 rows. Instead, I'll say, give me a sum of all the orders by country. There, it correctly interpreted that I'm looking for the actual monetary figure. So if I go into that spreadsheet again, and within the pivot table, I'll go to value field settings and then select the sum instead. Now, if I compare that against what we got back from the agent, the results are perfect. I'm just using this pivot table here just to verify the results that we're getting from the agent. So let's dig into exactly what that agent did. It first off called this get datasets from record manager. Then on the right hand side, we see it responded with these two files that we had previously uploaded, as well as a schema of those files. Within the response for this, we get the record ID, which corresponds to that particular file. Then when the agent decides which file it wants to query, then it goes and queries the tabular rows for that particular file based on this ID. So it has decided on the file, it has constructed a full SQL query for this particular question. So it selected the sum of the order amount, and it's also grouped that by the country and ordered the result. All of our individual row data is stored within this single table, and that's regardless of the schema. So you can have lots of different spreadsheets with different numbers of headings. All of these are serialized within this single JSONB column, and then we can query items within that using this syntax. So it is a very neat approach, and I'd like to give credit to Cole Meaden, who covered this on his channel and within his agentic RAG template. This idea of being able to serialize all of our data within one table negates the need to have to create lots of different tables for each structure. Now if I go back to this agent, okay, I'll ask another question of what ad platform did we get the most conversions from? And from there it responded in natural language. We got the most conversions from the Google ad platform. So if we look at that, we got 9 conversions, which is correct. And again, the SQL query looks okay to me. Before I explain the ingestion flow for these documents, it's important to note that there's no one-size-fits-all approach to RAG systems. You could decide to store your structured data both in the SQL database form as well as vectorizing it within the vector store. In general, I would choose to not do it because it may introduce a lot more noise within your vector database. If your spreadsheets are very small, then you could also alternatively store those within the vector database and then make sure your chunk size is large enough to be able to accommodate those. NLQ can work very nicely if you have simple data structures such as spreadsheet data. If you want to use NLQ on a database with lots of different tables, things can get very cumbersome. It might not work, or else you might need to be very prescriptive about your system prompting and potentially even fine-tuning. If you have a complicated schema, an alternative is to use a database view, which is kind of like a stored query, which effectively would serve as a staging area of that data for you to be able to query that view. If your database includes vast amounts of data you need to query, you could get even more complex and potentially denormalize a copy of your data into a star schema structure, which can be used in analytics systems. But let's reel it back and keep things a bit simpler for now. There is another drawback of storing data in this format, which is that if we store all of our data within this tabular document rows, we're keeping track of the schema of that file within this record manager table, but we're not providing examples of the data within this, or their data types, or their expected values. So there are some limitations there. We could potentially get AI to assist with that and then dump that into a separate field, but that would be an additional step. Let's walk through the process of how we import this data into our database. But if you want to get a head start with this, then check out the link in the description because we'll be sharing the blueprints with our community. Before getting into it, to zoom out, this section of the workflow here handles both the creation and updates of files. So it's going to listen out for lots of different file types within Google Drive and then be able to process those separately. For unstructured files, these go through the embedding process and are stored in the vector database. And for CSV, Excel, and Google Sheets, these are handled separately and then go through our process to be stored in our relational database structure. If you haven't already done so, I highly recommend that you check out our RAG masterclass video, which is linked in the description, because this goes through the entire process for how you set up the pipeline for the unstructured data formats within this workflow. Whereas in this video, I'm following on from that to handle the structured data formats as we see here. So at the very start of the process, we have two triggers here. We have new files and updated files. So within our Google Drive folder here, new files get automatically picked up by this, and if files are updated, they also get picked up by this workflow. Unfortunately, n8n does not have a trigger to watch out for deleted files. So as a workaround, we have a separate recycling bin folder, and any files that are put into this recycling bin go through a separate workflow above where we delete all of the vectors and records from the database related to that file. So let's get back to the workflow where we have a new file within Google Drive. We have a loop over items node here, and that means we can then iterate through each of the files one by one that are received and picked up from this trigger. So if I click into that, it's just a batch size of 1, and from there we have a download file node, and then we're just downloading that file. So I've hooked this up with my Google Drive credential, and we've mapped the ID directly from the loop over items node and selected by file ID. And on the right hand side here, we see we have a binary file which is downloaded and then ready to use within the automation. From there, we have a switch node. And here we're checking the MIME type to try and figure out what type of file it is. So we're checking for Google Docs, for PDF, and for HTML. All those are classed as unstructured documents for this. And then we have text CSV, which is a CSV type. We have Excel, which is that format, and then Google Sheets, like so. From there, we get one file in, and then we have 1,000 items extracted from that. Whereas for Excel, we use an extract from XLSX. We're doing the same thing, we're mapping the binary data in, and we get a similar result. Whereas for Google Sheets, we're actually using n8n's built-in Google Sheets node for that, and then we're mapping to this credential. Instead of using the downloaded file, we can just map by the ID from the file that we got from the starting node. The output of this extract from CSV node is 1,000 items, and these would be 1,000 items that will be processed separately by n8n. But we're using an aggregate node to combine all of those into one array. So now we're merging the field back to one item. The first thing we want to do is to get the schema for this data. So if I go into the Excel sheet, I go to the very, very top of this, I want to get a list of the top level items. And this is an assumption we're making about the data in the spreadsheets, that they do have one top level row that we can derive the schema from. So from here, when I go to the array keys, this is going to get the top level data that we can represent the schema for that file. And we're using this summarize node. And here we're concatenating all of the data for the entire document in one. This is used for two purposes. Number one, if we want to send this structured data also to the vector database, it's nice to be able to have all of our data in one long string that we can send to the data loader, and then it can chunk up that data. We'll also create a hash from this data, which will tell us if we need to update the data within our data store. So if the original file is updated and if the hash is different, that means the file has changed and we need to update our data. After that, we just have this merge node where we're branching back these inputs together and we're combining them into all possible combinations. So we just have the result from the array keys and the result from the concatenated data. From here, we're merging our flow so that regardless of what type of document came out of this switch, we're merging it back all to the same track again. But before we do that, we need to consolidate our data together. and we need to have it in a consistent format. So we have this set text node here. So within the set text merged, this has all of the fields that will be relevant for both the vector database unstructured documents as well as the structured documents. When you have discrete flows within your document, such as this and this, you want to find fields that will be able to represent both of those. And that's what I've done within this set text node. So I have the overall text, which we could send into a vector embedding model. We have the data type, so this is either going to be tabular or unstructured. We have the array keys, so that will be the overall schema. And we have the data rows, so this would be 1,000 rows sent from the CSV file. And a nice trick within n8n is that we can set the text like so and use this JSON variable to get the data from the previous node. And when we do that, it means we don't need to manually define which node it's coming from. Regardless of which route came into this node, it will take the previous node's data. So we're setting the text, array keys, data types, and data rows, and like so as well here, and the same for in here. And then when we're merging these together, we can merge it like so. That's just an easy and readable way for us to merge data together within n8n. Now from there, everything goes through one track. Within this generate hash function, we're using SHA-256 as the hash type, and for the value, we're just passing in the text of the document. And from there, it's going to generate that hash, and then we can use that to compare later on. Within our Supabase account, we have the record manager, and this is the central repository of all of the files, as well as the hash, as you see over here, and the Google Drive file ID. If you need to set up that record manager table or the Supabase connection, then make sure to check out that RAG masterclass as Daniel goes through that in detail. But within this table, if you've created a new file from scratch, there'll be nothing within this record manager for that file. But later on, if you're updating that file, there will be a positive result within the record manager. So what we're doing is we're searching the record manager, we're checking to see if that record exists. And within that, we're checking to see if the hash within that table equals the hash that we just generated a few minutes ago. So we're checking to see if that file has changed or not. And that's the reason why we're checking this record manager up front. So from there, I've selected a Superbase account. The table name is record manager. And from there, I'm just passing in the file ID. And this is the Google Drive file ID. But I'm referencing the loop over items because if we're iterating through multiple files, then we need to specify which file that is. So we're passing that into this switch. And then within the switch, if the JSON is empty, so if there was no results from Supabase, then we're going to go and create that record within the record manager. Otherwise, we'll go through the update process. But let's start by creating that record. So creating the row within the record manager, this is a simple Supabase action within n8n. The resources row, operation create, and then we're defining below for each column. So we're mapping the Google Drive file ID, the hash that we just created based on the text of the file, the data type. So in this case, because it was structured data, this is marked as tabular data, the schema. So these are the array keys that we set earlier on. Again, this is just the top level information about the file, and then the document title. I made some small changes to this record manager database. There's document title, data type, and schema, all marked as text. I'm keeping things simple here, but you could also further normalize this column or create an enumerator. From there, we're going to merge that back with this update flow because we want to get the record ID that was returned from Supabase. If this is the second time going through the process, we might want to delete the previous vectors. I'll go through that in a minute. After we've merged these back together, we now have the record ID, which is a Supabase record ID. I now have a switch to check what type of data type is this. Is it tabular data or is it unstructured data? So if it's unstructured data, then we go through our process that we went through within the RAG masterclass, where we go through and chunk up all that data and then load it into the vector database. But to handle tabular data, we now want to add records to this tabular document rows table. Here, the first node is to delete the old data rows, and I'm deleting any rows where this record manager ID matches the ID from the record manager table. This will delete any duplicate data for that file, just in case this is the second or third time we're going through this process if we originally updated the file. So now while we're on this tabular document rows table, let's have a look at this because this is something that's not gone through in the RAG masterclass. We just have a few simple fields set up for this. We have an ID, which is the primary key. We have this created at timestamp. Record manager ID is a foreign key to the main ID in the record manager table. This just adds a constraint to the database so that if you try to enter in IDs that do not exist within the record manager table, you will come up with an error. So this just adds a little bit more integrity to your data. Then we have this row data field, and this is a special JSONB format. And you can just enter this in manually by going to edit column and then setting the type of JSONB. This is a special JSON binary format where we can create a flexible data structure and enter it in here. Then we can query these fields as if they are separate fields within the table. So it's pretty cool. If you have a massive amount of data within your spreadsheet, this could be a bit of a performance hog, but for most people, this should generally not be much of an issue. So once you have that table set up, then you can map it to this delete old data rows node. Then after that, we want to add each individual row from that spreadsheet file to this table. In order to do that, we're using the split out node. So earlier on in the process, we aggregated all of that into one single array. Now we're splitting it all out, which is the complete opposite of that. So we can process those separately and then upload those to Supabase. There's a little quirk with an n8n. When you're mapping that, you're actually mapping the field name. So I just have this separate set fields variable where I have data rows set up here. I'm mapping the data rows all the way from back here. So I'd set these data rows. And by the way, that's an array of rows. So it's potentially a large list of rows. And then when I reference that, and then when I split that out, I can just reference that within this fields to split out field. After that, instead of using a Superbase node to insert those rows, I'm actually using a Postgres node and then connecting to the Postgres database within the Superbase account. The reason for that is that I was running into issues with sending this row data, this JSONB data to Superbase via n8n's built-in node, and it just worked when I used the Postgres node. In order to connect to your Postgres database on a Superbase account, then you can add in a credential, and then within the Superbase account, go to database, which is over here, and then go to connect at the very top. Then scroll down to transaction pool, and then you can copy this out. So you can see the host is this section, the database is Postgres, the username is this part here, the database password you set up when you created your Superbase account, but you can also reset that if you want. From there, you should be good to go. When it works, you'll see this connection tested successfully, notification at the top. Once you've mapped all those rows, then the rows will get inserted to Supabase, and your tabular document rows will show up something like this. So you'll have your IDs. The record manager ID will be mapped to what you have within the record manager table, and then you'll have all your data serialized within this JSONB formatted field, which is called row data. Then after that, it maps back to this do nothing node. So this is merging back with the other flow. That's just here for aesthetics to make the diagram look nicer. And then we go all the way back to the very, very start, which is the loop over items. So if there are multiple files, then it will go through this exact process again. And later on, if we update a file, it will go through the process. And then down here, the only difference is that within this switch node, we're checking to see if the hash from the file is the same as the previous hash. If it's the same, we just go straight back to the start because we don't want to update any vectors, don't want to update any tabular data. But if the hash is different, that means that the file has been updated. If the file has changed, we're going down through this part of the track where we're deleting the previous vectors and updating the record manager. And Daniel goes through that in the RAG masterclass in more detail as well. That's the overall data ingestion pipeline for inserting and updating files. Whereas when we're deleting files, this is exactly the same as the process Daniel went through in the masterclass, whereas I've also added in a section to delete the old tabular data rows, and the settings for this node is exactly the same as the settings down here when I deleted all old tabular data rows before making any updates. So once you're happy with this overall RAG ingestion pipeline, then you can also add plenty of more items that are also mentioned within the RAG masterclass, such as hybrid search, web scraping, and much more. But for the moment, let's get to one of the most interesting parts, which is the setup for the AI agent. So this is a simple AI agent with an n8n. I have this when chat receive node, and within the AI agent itself, the input or the user message for the prompt is like so. From there, we have a simple system message. So in order to test this out, I'm going to ask it a simple question. So I'll just ask it, how much money did the electronics department make? Okay, from here, it's querying the get data sets record manager. From there, it looks like it created a SQL query for the tabular row. So it says the electronics department made a total of this. So let's have a quick look at the query tabular rows. Select sum total order amount from tabular document rows. So this looks like the right table, where record manager ID equals 20 and row data department equals electronics. That query looks okay to me. If you understand SQL, you might find this part interesting. I've just pasted this into a SQL beautifier, but if I look at the sum, I see we have select sum, and then we're getting this row data and querying the total order amount field from within that flexible data structure that we have over here. And then the AI is casting this data into a numeric data type. So it's guessing that this data is a number. It's calling the field that, which you can ignore. It's taking it from this correct table, and where the record manager equals 20, and where role data department equals electronics. So again, it's querying the flexible JSONB data structure there, and then coming out with a successful response. So let's look at the AI agent system prompt for this. I'll just expand that out. So you are an enterprise assistant helping users access information. You can make that more specific for your use case. You are tasked with answering a question using the information retrieved from the attached vector store. And you can pause the video here if you want to look at this in more detail. When answering the question, query the vector store to attempt to retrieve the data. So here we're trying to give it permission to either query the vector store or to query the database. And here the operating procedure is to try to get the available data sets so it at least knows the schema and the file ID before then querying the actual database to get the data. So your goal is to provide an accurate answer based on this information. If you cannot answer the question using the provided information, or if no information is returned from the vector store, say, sorry, I don't know. And that's pretty important to say this, because otherwise it could just make things up and hallucinate while trying to be helpful. That's the system message. Within the tools here, we have this vector store, which we've gone through within the RAG masterclass. And then these are the two interesting parts here. We have the get datasets from record manager. This is a Postgres tool. The description is use this tool to fetch all available documents from the record manager. This will include the table schema and the ID. Here we're defining the record manager, where the data type is equal to tabular. So we only want to return records which are marked as tabular. Otherwise, anything marked as unstructured would have already been sent to the vector store, so we do not need these to be returned here. And then the output columns is the ID, the document title, and the schema. We're trying to restrict the fields that we're getting back, and particularly not including this Google Drive file ID, because we don't want the agent to get confused about what agents to pass to the next tool. On the right-hand side here, you see it has access to both of these files, both the order data and the ad spend, as well as the schema. So it has enough to be able to attempt constructing SQL queries for this data. And now within the query tabular roles tool, if we expand this out, this is a pretty long description, which is to execute a SQL query on the tabular document roles table. Instructions of you will always be querying based on a specific ID. So it's really important that it tries to get the data for one specific file at a time. Each row in the table contains a row data field of type JSONB that holds the data for that row, with keys matching the file schema defined in the record manager table. The record manager ID is the ID field from the record manager table, always filtered based on this specific ID when querying the tabular document roles table. When writing your select clause, extract values from the row data JSON using this operator and cast them as needed. So casting being to cast it to a specific data type. Items within your select needs to use the data within the row data fields. And here we have some example queries. So you can pause the video if you want to have a look at those. This is a second example query, and that is a third example query. And then the operation for this is execute query. Then under the query here, we have this expression we're using from AI, and the agent will be able to populate the query based on that. So to do things a little differently, I can go to make chat publicly available. From there, I'll save it and mark it as active. Now I've opened that up on my browser. Now I can ask that agent questions. So what department received the lowest amount of orders? Okay, I come back with the department that received the lowest amount of orders is industrial with 39 orders. And next I'll ask it a question of how long does shipping take? So that hopefully should be querying the vector store now and not our relational database. Here it gives us a long text-based answer. Now if I go to the execution history for those messages, I see in the first case it queried the Supabase vector store. If I click into the vector store, I see that a bunch of chunks were returned based on the query. Then it constructed the answer based on that. Then for the previous message of what department received the lowest amount of orders, it successfully used NLQ and queried the tabular rows. We'll be sharing these blueprints within our community, as well as all of our other advanced RAG content and course material. If you really want to go a level deeper and level up your agents, then this is the community for you. We've got an active discussion board, multiple live workshops per week, and access to all of our courses with more on the way. Thanks for watching.